All right, now we're getting into factoring our polynomials. And factoring is one of the key components to algebra. We're going to start by using like the backwards method of the distributive property to factor, and eventually we'll get into factoring quadratics. So the first thing, I guess mathematically, it means to express a polynomial as a product of a monomial and a polynomial factor. And factor, right, we're finding factors. That's how you actually factor polynomials. So let's just review our distributive property. If I had 5x times this sum, 4x plus 7, I just distribute, right? And I take 5x times 4x and 5x times 7. And then we simplify that into 20x squared plus 35x. Okay, what we're going to do is we're going to take that 20x squared plus 35x and we're going to work backwards and we're going to factor out that 5x, which we just distributed. And if you notice, that 5x is actually the GCF of that polynomial, of each monomial, right? 5x goes into both 20x squared and 35x, and it's the GCF of the two, the greatest common factor. So that's all that's happening. We're going to take the GCF of that polynomial, and we're going to factor it out. We're basically going to pull it out, kind of working the distributive property backwards. So let's take a look at that. So before we get into these examples, I got that same thing we just had, 20x squared plus 35x. And we just talked about 5x is the GCF that we want to pull out. Because if we look at the 20 and the 35, the GCF of those two is 5, right? 5 is the greatest factor, the greatest common factor between the two. And if I look at an x squared and an x, the most I can pull out is an x, right? Because I can't pull out an x squared to that second one. I can't factor it out. So I basically want to find the GCF of that polynomial. And like we said, it's 5x. So I want to pull out a 5x out of that binomial I have there. Really, I'm dividing each term by a 5x. I'm dividing each term by a 5x. So if I divide that 20x squared by a 5x, I would get 4x. So I pulled out that 5, and I pulled out an x. Still have an x left over. And then I also divided this term, 35x, by a 5x. I pulled out a 5x out of there, which leaves me with 35 divided by 5, which is 7, and the x's cancel. So there we go, 5x times 4x plus 7, which was what we started with. Okay, so let's look at this first example. 15w minus 3v. So we want to find the common factor between the two and the greatest common factor, actually, so we can factor that out. Well, if I notice 15 and a 3, 3 is the greatest common factor between the two. And then in this term I have a w, this term I have a v. Well, that's not common at all, so I can't pull either one of those out. Because if I pull it out, if I factor something out, it has to be in every single term. So there's nothing else I can factor out. Well, so I'm going to divide each term by 3. So 15w divided by 3 leaves me with 5w minus 3v divided by 3. Well, 3 divided by 3 is 1. I don't need to write that. And I'm still left with a v. And there's my answer. I factored out a 3. I factored out its GCF. So basically you just want to see what you can pull out of each term. Here I have a trinomial. Same thing. Find the GCF, but it has to be of all 3 terms. So I think about what number I can pull out of all 3 terms. I could pull out a 2, I could pull out a 3, but the GCF would be a 6. And then I look at their variables. The first one I have an x and a y. So basically that's probably the most I can pull out. The next one I have an x and 2 y's. Next one I have 2 x's and 4 y's. Well, the most I can pull out of all 3 terms is just 1 x and 1 y. I know the second one I could have pulled out 2 y's, but I can't pull out 2 y's out of all 3, right? I'm looking for the greatest common factor. What can you pull out, or what can you factor out of all 3 of them? So I'm going to factor out a 6xy. Really, I'm just dividing each term by 6xy. So if I look at my first one, 6xy divided by 6xy, well, I pulled all of it out, right? Well, there's not nothing there, because I'm really dividing, aren't I? A number divided by itself is 1. So there's still a 1 there. That's the thing. That can get very tricky, but you got to think you're actually dividing. You're not just straight up pulling it out. You're really dividing. So then I divide the second term, 24xy squared divided by our greatest common factor, 6xy. And 24 divided by 6 is 4. The x's cancel, and I'm left with a y. And I got a minus sign. And 30 divided by 6 is 5. And I pulled an x and a y out of there, so I'm left with an x and 3y. So y to the third. So there would be my factored form. 6xy times 1 plus 4y minus 5xy to the third. So remember, when you factor, you got to factor out every single term. Okay, we can also factor by grouping. This can get a little more confusing, but it's when we're dealing with a certain situation. Okay, so when we want to factor by grouping when there are 4 or more terms. If you noticed our last couple problems, one was a binomial, one was a trinomial. Now we're going to have 4 or more terms. That's why we want to group. The terms also have to have common factors that can be grouped. Okay, I don't want to group numbers that I can't factor anything out of. It doesn't make any sense. And when we look at an example, hopefully you'll see what that means. And lastly, there are 2 common factors that are identical or additive inverses. I like to deal with the ones that are identical, and I'll show you my trick how to make them all identical. Looking at it algebraically, let's say I had an expression ax plus bx plus ay plus by. Okay, there's a couple ways I could group this. If you notice, I have a common factor in these first 2. I have an ax and a bx, so I could group the first 2. In my second spot, I have y's, so I could group the y's together, ay plus by, and then I could factor out of each one. So in my first one, I could factor out an x, so I pull that x out, and I'm left with a plus b, right? I divide each term by x. In the second one, I'm going to factor out a y. I still have my plus sign here. Factor out that y, I'm left with an a plus b, right? Divide each term by y. Ay divided by y is a, by divided by y is b. And if you notice, I have an a plus b and an a plus b. This is where, this is why we group. When that happens, my rule is I can write my other term, my other binomial, as x plus y. So I can say x plus y times a plus b. That's my rule when I group. So that's my factored form. And if I went through and applied my FOIL method, I'd end up getting ax plus bx plus ay plus by. Okay? It might be a little confusing right now, but once we see an example, hopefully it'll make more sense. All right, we have 15a minus 3ab plus 4b minus 20. Okay, and when you group, you can always move around terms to do the grouping. For example, if I wanted to group the b's together, I can switch those around so I can group them. But I'm just going to go ahead and I'm going to group my first ones because I can pull out a 3a out of those. And I'll group my second one because I can pull out a 4. The GCF would be a 4 there. So let's take it step by step. Like I said, this first one, I can factor out a 3a. So I divide each term by 3a, which leaves me with 5. The a's cancel. Minus, well, 3 divided by 3 is gone, a divided by a is gone, and I'm left with a b. Okay, here I got my plus sign. Factor out just a 4. So I'm left with b, and 20 divided by 4 is 5. Well, it's kind of goofy, isn't it? I have a 5 minus a b, and a b minus a 5. So I need to do some mixing around here, don't I? Let's switch around my last one. So I'm going to say 3a, 5 minus b, plus 4, negative 5 plus b. Because that's a negative 5 and a positive b. To get those to match up, I need to factor out of the second one. I basically need to change each of those signs, don't I? Well, what can I factor out of there to change the signs? Maybe a negative 1, right? If I divide each term by negative 1, I'm going to rewrite my first one. And if I factor out a negative 1, that means I got to take that 4 times a negative 1, which gives me a negative 4. And the signs switch. Okay, so I factored out a negative 1 out of there. So to write that, pulling out a negative 1 to multiply. And now I have identical binomials here. So I can combine my 3a minus 4 and take that times 5 minus b. 5 minus b. Okay, some of these get a little more difficult than others, depending on how you group. Like this second one. Remember, you can switch orders around. I'm going to leave them just like they are. Oh, well, here I have a common factor of an x. If I would group these, I don't have anything to factor out. So maybe I do want to mix this around a little bit. I could rewrite this as 2xy minus 2y plus 7x minus 7. Because now I have a 2y to pull out of this first one. And a 7 to pull out of the second one. So I'm going to pull out a 2y out of this first one, which leaves me with just an x. And 2y divided by 2y is just 1. Plus sign, pull out a 7, factor out that 7. And I'm left with x minus, well, 7 divided by 7 is 1. And we notice our x minus 1s match up, so I can go ahead and combine these into a product of two binomials. So 2y plus 7 times x minus 1. We also have a zero product property. When you think about it, this should make sense. Basically, if I have the product of two factors and they equal 0, at least one has to be 0. So if I'm saying a times b equals 0, there's one of three things that could happen. A either has to be 0, b either has to be 0, or both could be 0. Right? But if a is 0, it doesn't matter what b is, because 0 times anything is 0. Same thing with b. If b is 0, a times 0 has got to be 0 no matter what a is. So that's what it's saying. As long as 1's 0, the whole thing is 0 if it's multiplying. Which brings us to a couple problems here. If I look at this first one, I don't know how to solve when there's a square in there, that b squared. So let's go ahead and let's try factoring. That's always a good method if you're not sure how to solve. See if you can factor anything out of there. Well, it looks like I can pull out an 8b, right? That's the GCF of those two. I'm left with a b right after I divide, and I'm left with 5, right? 40 divided by 8 is 5. The b's cancel, and that equals 0. So what my product property states is that I can set each of these equal to 0 individually, right? Because if 8b is 0, it doesn't matter what b minus 5 is, because 0 times anything is 0. Same thing if b minus 5 is 0. It doesn't matter what 8b is, the whole thing is 0. So I could say that 8b equals 0, and I could say that b minus 5 equals 0. And I could solve two separate equations. Well, in this first one, that's kind of nice. You divide by 8. b is just going to equal 0, right? 8 times 0 is 0. In the next one, we add 5 to both sides, and b equals 0. Or, my fault, b equals 5. Get going too fast. So if we look, b is 0, and it also is 5. And you could kind of look at your equation right away and say, well, how do I make this 0? We'll put a 5 in for b. So b equals 5 out here. How do I make that 0? Put a 0 in for b. So b equals 0 and 5. Some people can do this much quicker. Like this next one. If I look, same thing. If that's 0, it doesn't matter what this one is. Same thing. If this is 0, it doesn't matter what the other one is. So set them both equal to 0. X minus 2 equals 0. 4x minus 1 equals 0. So we add our 2 to both sides. X equals 2. Here we add 1. 4x equals 1. And divide by 4. So x equals 1/4. So we got x equals 2. And x equals 1/4. The quick trick to that one, I want this first one to equal 0. So x is 2. I want this one to equal 0. Well, I need this 4x to be a 1, right? Because 1 minus 1 is 0. Well, how do I get to a 4 to turn into a 1? Well, I want it to be a 1 at the end, so I'm going to put that in my numerator. And then I want the 4's to cancel, so I'm going to put 4 in the denominator. That's kind of my quick trick to figure out what you need for x. I wanted the 1, because 1 minus 1, and to cancel the 4, I put the 4 in the denominator. Or otherwise, you can set them both equal to 0 and solve. And lastly, okay, let's take a look at this last equation. I have 4y equal to 12y. My initial instincts are to divide by y on both sides to get rid of one of the y's, so I don't have that y squared, but that's not good. Whenever we get into quadratics or a variable squared, we don't want to get rid of them. A better goal is to get it all equal to 0. And when we get into quadratics, that'll make sense because we want to find our roots. So let's get this equal to 0. let's get everything to one side. So I'm going to subtract a 4y over here. So that's gone. I got 0 equals, can't combine these, so 12y squared minus 4y. I'm going to rewrite this up here so I got some room. And I'm going to put my 12y squared and 4y over on this side. Okay. And it looks like I can factor out a 4y. It's my GCF there. So I'm going to pull out that 4y divided by 4, 3, pull out one of the y's, and 4y, take the whole thing out. I'm still left with 1, right, because I'm dividing. Okay, and like I said, I can set both equal to 0. So if I set this first one to equal to 0, we know that y equals 0. And I could set the other one equal to 0, 3 minus 1. I'll write that out in a sec. But if we do my trick, I really want this whole thing to be a 1. So I'm going to put 1 over, well, to cancel the 3, I put it over 3. So y equals 0 and 1/3. That's that quick trick. Otherwise, I'd have to set 4y equal to 0, and I'd also have to set 3y minus 1 equal to 0, and just go through my algebra. Okay, but if you can get the shortcut, it does save you a little bit of time. And there's your answer. Okay, factoring is very important, so take your time. If you have any questions, feel free to ask.